Welcome to this follow-up video showcasing the UXG family of Keysight technologies. My name is John Meister, Application Engineer. And the configuration that I'm working with is a continuation of an earlier video, but essentially it's two 5194A vector UXG signal generators sharing a common N5193A UXG signal generator. And the outputs of both of these devices are connected to channels 1 and channels 3 of a high bandwidth Keysight oscilloscope. So you can see that on this screen here, and I've basically created a dual QPSK signal. Essentially the same signals coming out of both ports of the two individual vector sources, and I've got things pretty well phase aligned, so you can see that as I trigger this signal over and over again repetitively, that the phase of the sinusoids are effectively lining up. And what I wanted to just showcase was we have very precise capability of adjusting the phase on the signal independent of reloading the waveform. So what I'm doing is I'm manually triggering using the trigger key on the front of the source, and what I can do is simply put in an offset. So for instance, I will set in an offset of 180 degrees and then re-trigger, and notice now that the signal sinusoids are 180 degrees out of phase. I can then come back to a 90 degree phase offset for quadrature. So there's a 90 degree phase set, and then I can just return back to 0. So the signals are continuing to play even though I'm only triggering the scope as I control it. So I just wanted to showcase this, and we have the ability to adjust the phase in 0.01 degree increments, and as we're making those adjustments, the signal is always remaining present. It's not glitching or anything like that. So we have very tight and very capable phase control. Next, we're going to take a look at the amplitude walk and the phase walk. So first we'll start with the amplitude walk that we covered in the first video. So in this case you can see both signals which are pulsed in nature. They're actually 10 gigahertz pulses, 1 microsecond wide. The yellow channel is a reference set of pulses, and the blue channel is the second output from the slave vector UXG source. And you can see here how the amplitude is decaying on the blue trace relative to the yellow trace. So you can see this is basically an amplitude walk where it's actually stepping in 5 dB increments. Of course, we're looking at it on a voltage scale, so it quickly falls into the noise floor, but you can see what the the amplitude walk would look like. So the next experiment is to compare the phase in a phase walk of the blue channel relative to the yellow reference channel. So what I'm doing here is you can see the actual individual pulses of both channels, similar magnitude on both. You'll notice that my scaling is 10 microseconds per division, so every pulse is coming out at a 10 microsecond period, and the pulse widths are 1 microsecond. So the way we want to do this is first I want to just do a single acquisition. So here in this case the trace is now stopped. I've got an acquisition of a set of pulses, and we'll have to actually go in and zoom in on each one. So what I'll do is I'll work through each individual pulse by zooming in on it and go from pulse to pulse just to compare the phase walk. And if you recall from the earlier video, each pulse should be at about a 15 degree offset from one versus the other. So in this case what I've done is I've zoomed in on a specific pulse after doing our single acquisition. So you can see by my time on the x-axis here, I'm at one of the pulses that's basically negative 10 microseconds off of the main trigger point. So I'm catching this particular pulse, and I started here because you can see that the phase between the two pulses is effectively lined up on each other. So we have a very, very good agreement here. So what I can do is then step by incrementing the delay by 10 microsecond segments, and we should be able to do the adjustment of going from one pulse to the next, and then you'll be able to compare the phase and watch how the blue trace phase changes relative to the yellow one. So the first one I want to go to is the next pulse. So if I just click on 0 here, now we can see that the blue trace is advancing, and if I increment another 10 microseconds, there's a continued phase walk. I go to 20 microseconds to the next pulse. And again, the increment here is effectively 15 degrees per change, and 30 microseconds. If I go to 40 microseconds, continuing to change it to 50 microseconds. And you can see I got to the end of the acquisition. But you could exactly tell that each pulse, one to the next, had a walk that was fixed that modified or was modified by a 15-degree increment. So we'll run through that one more time. In this case, I'm starting at a negative 69.5 microseconds, and you can see that the phases are aligned. If I enter in the value of the previous pulse, which would be negative 59.5 micro, you can see the blue trace is shifting to the left. And through the magic of video editing, I will continue to do this at a high rate of speed. So you can see the power and the flexibility of phase and amplitude control with the Keysight N5193 and N5194 UXG signal generators. Contact Keysight Technologies if you have any questions.